Hello students, today we are going to see the comparison of electrovalent and covalent compounds from the lesson chemical bonding. So today's comparison between the electrovalent and covalent compounds, we are going to see 6 important properties. Now we are going to compare the 6 important properties. The first one is nature. How the nature of this electrovalent compound would be. How the nature of the covalent compound would be. So what is the reason behind the property? That's it. The first one, their constituent particles are ions. Electrovalent compounds are being present in the form of ions, and also they are hot solid consisting of ions. So they are present as hot solids which consist of ions. So what is the reason for this? 2 points. These have strong electrostatic force of attractions between their ions which cannot be separated easily. So since it is being in the form of solid states and these electrovalent compounds are being in the form of ions, are being present as ions, hence it is not possible to separate easily and which cannot be separated easily. Compared to that covalent compound, their constituent particles are molecules. These are gases or liquids or soft solids. So in covalent compounds, the particles are made up of molecules, not ions, remember. And these are gases or liquids or soft solid. What's the reason? They have a weak force of attraction between their molecules. Here, the strong force of attraction results in the formation of hot solids, whereas here the weak force of attractions between the molecules results as a gases or liquids form of covalent compound. Sometimes it may be soft solids also. Second property is boiling point and melting point. So what is the boiling point and melting point compared with electrovalent compounds and covalent compounds? These are non-volatile with a high boiling and high melting points. These electrovalent compounds are high volatile, non-volatile with a high boiling and melting points. So what is the reason for this? Because there exists a strong force of attraction between the oppositely charged ions. So a large amount of energy is required to break the strong bonding force between ions. So there is a strong force of attraction. Since the electrostatic force of attraction is more, a strong force of attraction is forming between the ions present in this substance. So a large amount of energy is required to break the bonding. It is not so easy to break the bonding. We have to give a large amount of energy to break the strong bonding force between the ions. So because of this reason, they are non-volatile with a high boiling and high melting point. But in this case of covalent, these are volatile with low boiling and low melting points. So why they are volatile and how their boiling and melting points are low? Because they have a weak force of attraction between the binding molecules. Thus, less energy is required to break the force of bonding. They have a weak force of attraction between the binding molecules. Thus, less energy is required to break the force of bonding. Okay. Third important property is electricity conducting nature. So, how they are conducting electricity in terms of covalent compounds and electrovalent compounds. First, in electrovalent compounds, they do not conduct electricity in the solid states, but they are good conductors of electricity in the fused or in aqueous state. So you should know the difference between what is the fused state and what is the aqueous state. In solid states, they are not conducting electricity, clear. So why they are not conducting electricity in solid state? Because the electrostatic force of attraction between ions in the solid states are very strong. They are having a strong force of attraction, hence electricity conduction is not possible, or they are not conducting electricity in the solid states. Whereas in aqueous states or fused states, the force weaken in fused state or in solution state, hence ions become mobile. So aqueous states means the substances which are present in the presence of water, aqueous states. Fused states, when they are heating to the higher temperature, a liquid like a substance obtained is nothing but the fused states, the electrolyte compound which are being in the fused states. So, solid states, they are not conducting electricity, and in fused states or aqueous states, they are a good conductor because of the weakened force and the mobility of ions. So what about in covalent compounds? Electricity conducting nature. They are non-conductor of electricity in solid, molten or aqueous states because of the absence of ion. The reason is the ions are absent. Here the presence of molecules only the presence of molecules. So because of the absence of ions, they are not conducting electricity. Okay. Third, fourth properties, dissociation and ionization. Here in covalent compound we are talking this as dissociation, and electrolyte compound we are talking this as dissociation, and covalent compound it is known to be as ionization. So before knowing this, we should know what is dissociation and ionization. So dissociation means it is a separation of ions which are already present in an ionic compound. In this covalent compound, the ions are already present. They are getting separated by means of the reaction. Dissociation, that is called as dissociation. Whereas ionization, which occur in the covalent compounds. So this ionization is not present initially. It is formed during the course of the reaction as positively or negatively charged ions. It is formed as a positively or negatively charged ions, known to be as a ionization. Okay, let's see in electrolyte compound dissociation. Electrolyte compounds are composed of ions. In solution, these ions become mobile, or in molten states, these ions dissociate. So in solutions, the mobility of ion is possible, whereas in molten states, the ions dissociate themselves. The reason, water being a polar covalent compound decreases the electrostatic force of attraction, resulting in free ion in aqueous solution. So water is a polar covalent compound, as we know well, and this helps for the dissociation of ions into the positive negative. For example, sodium chloride salt is being added with the water. It dissociate into Na plus ion and Cl minus ion. So their ions dissociate and migrate. When an electric current passes through them in their molten or aqueous solution state, the either positive charged Na plus or negatively charged Cl minus are moved to the respective poles, respective points when on passing the electric current. So ions dissociation in water or in molten states. So the reason is ions dissociate in water or in molten states. So because of this reason, electrolyte compounds are good conductors of heat. What about in ionization, that is covalent compound? On passing electric current, non-polar covalent compounds do not ionize because covalent compounds do not have ions. We know that consist of only of molecules, so don't have ions. Hence, covalent compound that ionization and is not possible on passing electric current to the non-polar covalent compounds. But some of the covalent compounds are polar in nature. They ionize in the solutions and can act as an electrolyte. For example, HCl, hydrogen chloride, on being react with the water, it forms as hydronium ion and a chlorine ion. So because this HCl is act as a covalent compounds in polar nature. So polar covalent molecules forms ions in their solution. It is not applicable for non-polar covalent compounds, only for the polar covalent compounds, and they are ionized in their solution state. The dissociations of molecules into ions does not take place in covalent molecule. Covalent compounds do not have ions, so they do not dissociate. So dissociation is not possible in the covalent compound. And the covalent compounds are poor conductor of heat. Fifth property is solubility. These are soluble in water but insoluble in organic solvent. What are electrovalent compounds? The reason, as water is a polar compound, it decreases the electrostatic force of attraction, resulting in free ions in aqueous solution. Hence, they dissolve. So, water is a polar compound, we know well, and it decreases electrostatic force of attraction, or it reduces the force of attractions to mobilize the ion, but it decreases the force of attraction, resulting in free ions in aqueous solutions. Hence, they dissolve. So, they are soluble in water but insoluble in organic solvents. What about in covalent compounds? Solubility. These are insoluble in water but dissolves in organic solvents. As organic solvents are non-polar, hence these dissolves in non-polar covalent compounds. So, these covalent compounds are non-polar, generally in non-polar states. When it is a non-polar, dissociations or ionization is not possible. So because of this reason, it is insoluble in water but dissolves in organic solvent. So ionization does not occur in the water but dissolves in the organic solvent. Okay. The last property is the rate of the reaction. Electrovalent compounds, they shows a rapid speed of chemical reaction in aqueous solution. So electrovalent compounds in aqueous solutions, we know that it forms ions. It dissociates and forms as ions. So because of the ions, the movement of the availability of electric current is passes through them. That results to the speed of the reaction. So that is the sixth one. They show rapid speed of chemical reaction in aqueous solution. The reason just I told. Since free ions are easily formed in different solution, they unite very fast, forming compounds. So this is the reactions. It occurs at faster, resulting in the formation of compounds. What about in the covalent compounds? The rate of the reaction show slow speed of chemical reactions in aqueous solution. Very slow. In covalent molecules, old bonds are broken and new bonds are formed. Thus, the reaction is slow between covalent compounds. We know that in electrovalent compound, it is in the form of ions, it dissociates easily, hence the reaction is fast. Whereas in the covalent compound, it is being in the form as molecules. So, the molecules, it has to break the bond first of all, and the new bond has to form. So, this takes much time compared to electrovalent compound. Hence, the rate of the reaction is slow. Okay, students. Thank you.